So for problems 4 through 10, I'm asking you to actually write matrices in terms of the three matrices that we talked about in class. And remember, those three matrices consist of what we call the coefficient matrix, which is basically all of the coefficients in front of, or the numbers that are in front of these variables. So these are coefficients. And then there's another matrix we can make called the constant matrix, which are basically all of the solutions here. And then if we put all those together, we get what's called the augmented matrix. So let's go ahead and write all of those real quick and make sure you remember how to do that. So remember, the constant matrix is made up of, the coefficient matrix is made of all the coefficients in front of variables. So in this first row, for instance, we have a coefficient of 1, -2, and +2. Second row, we have coefficients 2, -3, -2. And on the third row, we have coefficients 1, -1, and 1. So this is going to give us all our coefficients. And from this, we can also create what's called the constant matrix. The constant matrix is just these numbers that are sitting out here after the equal sign. So we have -1, 3, and -1. And this is what we get when we create again, this first matrix right here. It's called the coefficient matrix. The other matrix out here, it's called the constant matrix. If we put the coefficients with the constant matrix, we get what's called the augmented matrix. And if you look at number 6, 6 asks you to write the 6 wants you to make the augmented matrix. So let's go ahead and make that augmented matrix. And here's how we do that. Again, we first identify the coefficient matrix. Coefficient matrix is 1, -1, -3, 2, and notice there's no y variable, so we'll put a 0 there, 3, and then we have 3, 2, 1. And remember, we use the imaginary, the dashed line shows it's imaginary, we're augmenting it, bringing it together basically. You have the variables, the numbers, -2, 5, and 4. And this is what we call the augmented matrix. Now, on problem 8, 8 is asking me to go backwards. They want me to write the system of equations from the augmented matrix. So I want to write system equations from the augmented matrix. There are two types of equations we can write. We can write those equations through the variables using the variables x and y, or if we have 3 variables, it would be x, y, z, or if we have 4, it could be w, x, y, z, whatever you want to call them, or you call them different letters. So we would have, this is the x column. Remember, we go in columns here. This is the y column. And here's the augment for those variables. So there's x and there's y. So we could write that right like this, going it as 5x plus, just call it a y, 5x plus 7y should equal 1. And the other one would be 4x plus 9y is equal to 5. Another way we could do it, though, is using the general form, or the general linearization, which uses the only variable is x and we subscript them. So we could call this x1 and x2 instead and rewrite it like this: 5x1 plus 7x2 is equal to 1, and 4x1 plus 7x2 is equal to 5. This we call the general, and this right here is just using variables x and y, traditional linear systems that you normally see.